Hello, welcome back to Python programming tutorial. In this tutorial, you will learn about bitwise operator. So, a bitwise operator in a Python is used to perform a bitwise operation, and the whatever value that we are giving to the Python as an input, that will be first converted into binary form, and then the Python will perform a bit by bit operation, and therefore it is called as a bitwise operator. But however, the result that we will get is a decimal number from the Python. So here is the list of bitwise operator. With the help of this ampersand, we can perform a bitwise AND operation, and we can write a syntax in this way. If our variable a and b, then a and b is representing a bitwise AND operation between a and b. And similarly, with the help of this vertical line, we can perform a bitwise OR operation. So it can be represented by in this way, A or B. And this tilde sign is useful for the bitwise NOT operation. So it will do a complement of this A, and it is represented with tilde A. Then this caret sign is useful for performing the bitwise XOR operation, and we can do in this way A XOR B. Now the Python is also supporting the bitwise right shift as well as the left shift. So with the help of two consecutive greater than sign, we can perform a bitwise right shift, and we can write in this way. Here we can mention the number of time we want to shift, and similarly with the help of two consecutive less than sign, we can do a bitwise left shift, and it is a then 2 times less than sign. So let's see everything in a Google Colab practically. That will give you a better understanding about the bitwise operators. So let's start with the bitwise operator. So first of all, we will see the bitwise AND operation, and let's take a binary number a is equal to 1 0. So this is a binary number 1 0, which is in integer, it is a 2, and here we have another binary number that is 0b 1 1. So this 1 1 is representing 3 as an integer, and we are going to perform the AND operation between these two. So you can see in the truth table that in AND operation, if both the input are 1, then and then output will be 1, otherwise our output will be 0. So after the binary operation, our output will be 1 0, that is a 2 in integer, and in binary it is a 1 0. So let's check. So you can see that our output is a 1 0. If you do not write this binary function, then by default Python will result in an integer value. So let us check. I am going to remove this binary function, and now we are going to do a and b operation, and you can see that our result will be a 2, because this is a 1 0 and this is 1 1. So therefore our output will be a 1 0, and in integer it is a 2. Even if you will give the integer over here, and let's say another integer over here, and then we will do a bitwise operator, then again it will perform the bitwise operation between these two in binary, and then it will give a result as a output in a integer form. So again our result will remain same. So this is how the Python is exactly performing the bitwise AND operation. So next we are going to see a bitwise OR operation, and you can see the truth table of OR gate, and here we have again a two input a and b, that is in binary form, that is 1 0 and 1 1. Now in OR operation, if any of the input is 1, our output will be a 1, and therefore in this case after the OR operation between a and b, our output will be 1 1, that is 3. So let's check. So here you can see that in binary we have 1 1. This is binary result because we have again used the binary function. If I will remove the binary function, then it will again give a result in an integer form, and that will be a 3. The next operator that we are going to discuss is a bitwise XOR operator, and it can be done with this caret sign. Let's have a is equal to 0 b 1 1 and b is equal to 0 b 0 1. So in the XOR operation, if both the bits are equal, then our output will be a 0, and in this case our output will be a 1 and 0, because these two are equal, so it will become 0, and these are the opposite one, so therefore a 1 0. So we can see it with the help of running this cell, and you can see that output is a 1 0. So this is how you can perform a bitwise XOR operation in the Python. So next I am going to tell you about bitwise NOT operator. And before we discuss about bitwise NOR operator, I will tell you how you can read binary number easily. So generally binary number are represented with base 2. The LSB is represented by a 2 raised to 0, and then we have other digit. I have represented 8-bit binary digit over here, and therefore it goes up to a 2 raised to 7. If I will write the decimal value of this numbers, then it will be 2 raised to 0 means 1, then we have 2, 4, 8, 16, 32, 64 and 128. And let's say if I am writing a 4 times 0 and 1010, it means it has a value of this 1 and this 1, and therefore it is 8 plus 2, that is a 10. So the decimal value of this binary number is 10. So this is how you can easily read any binary number. Now let's talk about how the bitwise NOT operator is working. So let's consider a is equal to 1 0 in binary. This is a 2-bit number, and if you will read in a decimal way, so its value is 2, because you can see here 1 0, so it have a value of 2. So if you want to perform a bitwise NOT operation, you can use this tilde sign. So I have written here tilde a, and Python will do a complement of this number. So complement of this number means 1 will be converted into the 0, and this 0 will be converted into the 1. So this is the complement of this number, and that is what we mean by a NOT operation. Now if I will again convert this value into the decimal one, so it will be equal to this minus 3. Now if I will write this minus 3 into the binary again, so it will be a minus 1 1. So this is how Python is representing output in the binary. Now you must be thinking that how this 0 1 can be a minus 3, because this is the 2's complement value, it is a minus 3. So let me tell you how we can find out the 2's complement of the number. We want to find out the 2's complement of this 3. So I am consider 1 1 because it is a decimal value of 3. Then to find out the 2's complement, you have to do a complement of this number, which is called as a 1's complement. So here 1 is converted to the 0. If you have a 0, it will be converted to the 1. So this is the 1's complement of this number. Now to take the 2's complement, you have to add one more 1 to the LSB. That means at this particular bit, if you have even a 8-bit number or any bit number, you have to always a 1 to the LSB, and therefore this number is now 0 1, which is a minus 3. So this is how the NOT operation is working in the Python. So let's verify this in Google Colab. So for example, if we have a is equal to 1 0 in binary, so it will do a 1's complement. We can run this code and we can check that it is returning a 0 b 1 1. So as the 1's complement of this 1 0 is 1 1, so therefore it is a 1 1, and this positive will be converted into the negative. We can see this thing in a integer also. So this 2 will become a minus 3 because this 1 1 is a minus 3, and that's how the bitwise NOT operation is working. So next I am going to tell you about bitwise write shift, which is quite easy. So this is the syntax of bitwise right shift. We have A, which is a number, and it will be shifted towards the right side by the value of B. Let's take one example. Let's consider A is equal to binary value 1010. Now I want to shift this A towards the right hand side by the two values. So this value will be shifted towards the right hand side and it will add the two zeros at this place. So my new number will be 0010 and this 10 will be discarded by the system. Now if I will write a 3, then this 3 number will be discarded and here we will have the 3 zeros. Now if you will observe this value, so here 1010 means which is a 10. You can see here it is a 8 and 2. So therefore the number is 10 in decimal. Now if I will shift it 2 times, so we have a value as only 10 which is a 2. So our answer is a 2. Now how we are getting a 2? Because this bitwise shift is same as dividing a number A by 2 raised to B. Now B is, we have a 2, so therefore 2 raised to 2 which is 4, and if I will divide this number 10 by 4, so it will be a 2.5. So Python is representing this 2.5 as a 2, and that's how the bitwise right shifting is also dividing a number A by 2 raised to B and storing it again to the A. So let us see right shift operation. Let's consider this A is equal to 0B1010, that is a binary number 1010. Now if I want to perform a right shift, I can do A and then 2 consecutive greater than sign, so it will perform a right shift, and I want to shift only a 1 time, so therefore I have written as a 1. So let's check in the binary first. So here you can see that after the bitwise operation the number is becoming 0101. This is just a 3-bit number, so therefore it is 0 is omitting over here, otherwise it is a 0101. And you can also check over here, this is the integer value 10, and if I will do a 2 raised to n, that is a 2 raised to 1, so it will be divided by 2 and our result will be 5. If I will do a 2 shift, then the result will be a 2.5, but the Python will return only a 2 because it is giving a integer value only. So this is how we can perform a bitwise right shift in the Python. So next we have a bitwise left shift, which is very same as bitwise right shift. So here you can see the syntax. A is 2 times less than B. A is a number and B is a value by which you want to shift this number towards the left hand side. Now let's take one example. A is equal to binary value 1010. Now if I will take A with left shift of 2 times, so this number will be shifted towards the left side by 2 times. So it will do, the Python will do this by adding a 2 extra 0 over here at the LSB, and that's how we have our output as a 1010 and then this 2 extra 0 at the right hand side. And this bitwise left shift is similar to multiplying a number by 2 raised to B. So you can see that the decimal value of this number is 10, and if I will do a bitwise left shift, then this number will become a, here we have a 0 0, and then we have again 0, then we have a 1 0 1. So this is a 32 and this is 8, so therefore we have a total 40, and therefore you can see that here we have a 2 raised to B. We have to multiply this number by 2 raised to B. 2 raised to B means 2 raised to 2, which is a 4. So 10 4 is 40, and that's how we are getting this number as a 40. So this is how the bitwise left shift is working. we have a bitwise left shift in the Python that can be done with the help of two consecutive less than sign, and here you can see that we have a is equal to 0 b 1010, and it will be shifted to the left hand side. So this 1010, and there will be another 0 after this because it is shifted to a left hand side, and we have only do a one time shift, and therefore our output will be a 1010, and there is another 0 due to the left shift, and this is equivalent to multiplying a number by 2 raised to n. So in Python, if I will give a input as a 10, my output will be a 20 because it is multiplied with the 2 raised to n, and here n is equal to 1. So you can see that our output is a 20. If I will do a 2 raised to n, that is 4, so now my output will be a 40. So this is how you can perform a bitwise left shift in a Python. So in the end, I have one programming exercise for you, and you have to consider the two value a is equal to 6 and b is equal to 2, and you need to perform a bitwise OR operation on a and b and store the result in a variable c, and then do a square of the result using bitwise operator. You can practice this exercise by yourself, and you can write your code in a comment. We can discuss there. And thank you so much for watching this video. I hope you have liked this video. If you have not subscribed to my channel, please subscribe and support this channel. Thank you so much.